Okay, so online I've posted a practice final under week 10. You can work through it. So the practice final, a lot of these problems are all kind of calculation based, okay? That said, there is also going to be a section where there's conceptual problems, okay? Now it's hard to make example conceptual problems without making them like almost identical to the kind that you have. So I don't have very good example problems there. So the final exam will probably be about 55, 60 questions-ish, something like that. Okay, a large chunk, I'd say the majority of it will be hypothesis testing, confidence intervals, statistical inference, where I'm going to give you some kind of scenario and then ask you questions related to that. But there will also be a portion that is based on some conceptual topics, okay? And so I'd say there's about 10 questions on the final that cover that are in the realm of conceptual questions. So I thought, as far as kind of today's lecture goes, we'll cover these conceptual topics. Okay, maybe I'll maybe give you a few practice problems. And then as far as the other questions go, I think the practice final is fairly well representative of what the actual final will look like in terms of the computational questions. Okay, I will post the answers to the computational questions probably tomorrow or Friday, something like that. So tomorrow in section, I think I've told the TAs to work through some of these problems on the practice final. I recommend you do that as well as you guys try to study. And that's that. So, as far as studying goes, I'd say working through the practice final will be a very good help. If you struggle with some kind of like test anxiety, I would say when you work through the practice final, put yourself into test-like situations. I would say give yourself 15 minutes to work through kind of 6 problems. So these are kind of grouped together in in sets of 6 or so problems, and I would say give yourself about 15 minutes for each of these things. Put away all of your notes other than that formula sheet that I'll provide in your reference tables and whatnot, and see if you can work through it. Yes, question. Yeah, you can. You'll bring your own reference tables. Okay, so for the final, bring your own reference tables. I will provide the formula sheet, and that's that. Okay, bring your calculators and pens, pencils, whatever's erasers. Okay, so yeah, another question. It's all going to be multiple choice. Okay, everything's multiple choice. I would say maybe about 35 to 40 questions are going to be computational. Probably around 35 are computational, 10 are conceptual, and then you'll have kind of like a grab bag of a few definitions from prior to the second midterm. Okay. So I'd say a heavy focus on chapters 7, 8, and 9, and then a few random questions or arbitrary questions from earlier on in the course. Okay, and I kind of have a selection of those types of questions at the end of the practice final. So for example, a bar chart is used for what kind of data? Bar chart is for categorical data. Whereas, what do we use for numeric data? Histograms or dot plots or box plots, okay? So those are all options. So you know, something like that. And you know, I've got just a few questions related to stuff like that. But I thought today we'll focus on these conceptual topics here. Okay. So I'll kind of work through these. So it says a confidence interval provides a range of plausible values for the population parameter. A confidence interval for the value or the parameter mu1 minus mu2, if that thing contains 0, then you will not have evidence of a difference between the population means, which would be equivalent to not rejecting the null hypothesis. If, on the other hand, if the confidence interval does not contain 0, then you do have evidence of a difference between the means. Okay? And then a confidence interval is about the population parameter. It does not say anything about individuals in the population, future samples, or other sample means. It only provides information about the parameter. And lastly, confidence intervals are intervals and cannot confirm if the population parameter is equal to some value. Okay, did you guys get all that? All right, so let's do some clicker questions here, and I'll kind of make some true-false statements regarding confidence intervals, and you tell me what you think. So for all of these, A is true, okay? A will correspond to true, and B will correspond to false. Oh, okay. I gotta move this. How do I do? Darn computer. Okay. Let me zoom out a little bit then. That's okay? All right. Okay, so I will say, okay, so you create a confidence interval for mu, and get an interval of 1.2 to 3.5. Okay, so this will be true, false. We'll say you create a 95% confidence interval for mu. Okay. True, false. I am. Wait, hang on. Okay, sorry, I got to fire up. The clicker program here. Okay. All right, so true or false? I am 95% confident that these okay, so ready, go. Hang on. All right, is that running? Okay, it's running. A is true, B is false. Shoot. Darn it. Of course, click the wrong thing. Okay, did we get our clicks in? I'll say just a couple more seconds here, and we will stop. Okay, the answer here is false. Okay. If we wanted to make it true, we have to say I am 95% confident that the population mean is between 1.2 and 3.5. That would make it a true statement, okay? But regarding the sample mean, the answer is no, because there's no uncertain, we know what the sample mean is, okay? What would the sample mean be? It would be halfway between 1.2 and 3.5, right? Okay, because that's what we're using as our basis here, okay? Okay, true, false. Our confidence interval provides evidence that the population mean is not 0. Okay, so go ahead. True or false? Okay, and what is our answer here? The answer is true. What's going on here? Ugh. Okay, oh, here we are, okay. All right, so our confidence interval provides evidence that the population mean is not 0. That is true, okay? We have evidence that the population mean is between 1.2 and 3.5. So we would say, values between 1.2 and 3.5 are plausible. 0 is outside of this range, so it is not a plausible value. All right, I guess I can start clipping these. So this one is true. Okay, we'll do another question regarding our confidence interval. Okay, true or false, our confidence interval, let me hide the graph here. Provides evidence that the population mean is 2.5. And we'll go there. Okay, let's get our clicks in. Confidence interval provides evidence that the population mean is 2.5. What do we say? Okay. Okay, and so our answer for this is false. Okay. Okay. So why is this false? Okay, so it is okay to say that 2.5 is a plausible value of the population mean. That's okay, okay? However, our CI, confidence interval, does not confirm that the population mean is actually equal to any particular value. So it just says 2.5 is a plausible value, but it doesn't confirm that it definitely is equal to that value. So for this one, the answer is false. Okay, so this is the explanation. Do we have questions on this? For both questions, there is a non-insignificant minority that got the question wrong. So I just want to make sure we're comfortable with this before moving on. So, yes, question.
For the first of the two.
Uh-huh. Okay, so this, okay. So we'll go back, all right, and so let me just go back to that statement. Okay, so we says that one said our confidence interval provides evidence that the population mean is not 0, and we said this is true. Okay, if the statement said our confidence interval or proves that the population mean is not 0, this would be false. Okay, so it's okay to say we have evidence against this claim. Okay, we can say we have evidence against the claim, and that is fine. But confidence intervals don't prove things. With statistics, we can't really prove anything. All we can say is this is the evidence that I have. Okay, so is it possible? So even if our confidence interval goes from 1.2 to 3.5, so our CI goes from 1.2 to 3.5, okay? Is it possible that our population mean is 0? Yes, it is possible. Okay. And that would mean that the data we observed was an unusual sample. Okay? Because according to the central limit theorem, our samples should produce sample means that are close to the population mean. And if the population mean is 0 and our sample leads us to create this confidence interval of 1.2 to 3.5, then that means the sample we got was very unusual. Okay, I guess I'll throw this in our notes. Up here. All right. Okay, and then so other statements we can say about the confidence interval, and I'll just go ahead and say this statement is true. So I'll just make a few things. So false would be there is a 95% probability that the population mean is between 1.2 and 3.5, okay? false would also be 95% of values in the population are between 1.2 and 3.5. Also false would be 95% of samples will have sample means between 1.2 and 3.5. Okay? What would be true is that if 100 samples were drawn from the population, and each sample produced a 95% confidence interval, we would expect 95% of those confidence intervals to capture the true population mean. Okay. So I know I generally don't like to type on the screen because I type way too fast for you guys to keep up with your handwriting, and so that's why I generally write things out on the board. So I don't want to say like don't take notes, but today's session is mostly kind of just to present some questions or like type of questions and answers that that you can use, okay? Or that what am I trying to say? So the questions on the final will not be true-false questions. These conceptual questions will not be true-false, but it'll be some kind of question, and it might say like, which of the following statements are true? And you'll probably see some of these false statements available as wrong answer choices. Okay, so I'm putting these out here so you can kind of identify which statements are definitely going to be false. Okay, and I'll put these, publish these online as part of your, so you can study. Okay, so those are some of the key points regarding confidence intervals. Okay, let's talk about hypotheses, because this is also another key topic. It says, regarding hypotheses, we will assume that the null hypothesis is true. Data is always used to support the alternative. We reject or we do not reject the null. We never accept the null hypothesis. Okay, we support or do not support the alternative, and we never reject the alternative here. Okay, so let's use that, and we'll say which of the following statements are true, or which statement is correct, I'll guess. Okay, so the question will be, you perform a hypothesis test to see if the proportion of whatever is less than 75%, okay, 0.75, okay? The p-value for this test is 0.01, okay? You used an alpha of 0.05. Okay, which statement is correct? We have evidence that the population proportion is 0.75. We do not have evidence that the population Okay, so these all look kind of similar, but only one of these is correct. Okay, so which statement is the one that's correct? All right, so keep in mind, try to, as you're reading this and you're trying to figure this out, what did I do again? Darn this. Okay, so as you're trying to, try to figure out what your null and alternative hypotheses should be, and work accordingly. Okay. Okay, so I know they all sound similar, but we want to be able to distinguish the correct statement from all of the false statements. Okay, so I'm going to hit stop here in a couple seconds, so just get your clicks in. Okay, let's see. The correct answer is C. Okay, but there's still a portion of you that are missing these questions. So I kind of want to just make sure we have some understanding here. All right, so. Okay, so regarding this question, all right, so you have to think, what would my null and alternative hypothesis be? Okay, so the null hypothesis always has an equal sign in it, right? So here we're talking about a proportion. So we've got P, and then we're going to test to see if the proportion is less than 0.75. So our null hypothesis always has an equal sign, so we're going to put that number 0.75 there. And then because this says less than 0.75, our alternative must be less than 0.75. Okay? What we find is our p-value is 0.01, which is less than alpha. So we have their p-value is equal to 0.01, and that's less than our alpha. So this tells us that so our p-value is less than alpha, so that means we reject the null hypothesis. Okay, and so rejecting the null means, remember we never say we accept the null, we either reject the null or we don't, and then we either support the alternative or not, okay? So in this case, we have evidence to support the alternative. So in this case, all right, so let's look at what these things say. Part A says we have evidence that the population proportion is 0.75. So this is basically, we have evidence that the null hypothesis is true, okay? We will never be able to say that the null hypothesis is true. So this is false, okay? We do not have evidence that the population proportion is 0.75, okay? So we do not have evidence that the null hypothesis is true. Again, we will never ever make a statement towards saying that the null is true. Okay, so A and B will never be correct. Okay, so we will never make a statement about the null hypothesis being true. Okay. We have evidence that the population proportion is less than 0.75. This is correct, okay? Because we have rejected the null, we have evidence to support the alternative. This is basically alternative is true. All right, in part D, this would have been correct if our p-value was something like 10%. In that case, we would not have evidence to support that the alternative is true. Okay, but this is not correct because our p-value is less than alpha. If our p-value was greater than alpha, answer choice D would have been the correct answer. Okay. You know, I mean, and I'm happy that 85 of you got it right, but I'm also a little. I just want to make sure those who got it wrong. I want to make sure this makes sense to you guys. So, and I know we might be shy in terms of asking questions, but don't be shy. Okay. All right. So I will go ahead and I'm gonna just turn these also into. So it could, you know, we could write these as we have evidence that we have evidence to support the null hypothesis. We do not have evidence to support the null hypothesis. We have evidence to support the alternative, and we do not have evidence to support the alternative. Okay, so these are. This is the exact same question. It's just instead of putting it in the appropriate context. Okay, I'm gonna turn this. Okay, so this is exact same question. Same question and same answers as the previous page. Okay, and so you know these are wrong, this one is correct, and this is wrong. Okay, and so the same reasoning that applied to the previous page applies to these answers as well. Okay, so all I've done is I've just changed it from whatever this is saying into this form. Okay. Okay. So this is these statements are written in the I guess in the positive form, talking about supporting the null. The same question can also be written kind of in the negative form. Okay. So we, except this would be, you know, we have evidence to support the null. The negative would have to be, we have evidence to, let me just change this, reject the alternative. We do not have evidence to reject the alternative. We have evidence to reject the null, and we have evidence to reject the null. Okay, so rejecting the null is equivalent to supporting the alternative. All right, so these answers also correspond to being the same thing. Okay. Okay, so just keep in mind that rejecting the null is equivalent to supporting the alternative. And you either have evidence or you do not have evidence to make this conclusion, okay? And we will never talk about rejecting the alternative. So again, A and B right off the bat we know are wrong because we will never talk about rejecting the alternative, okay? So it just really comes down to, do we reject the null or not reject the null? And that depends on how the p-value compares to alpha. Okay. So again, valid conclusions, rejecting the null or supporting the alternative. These are, you know, it's valid. Okay. Never valid will be support or accept the null, and rejecting the alternative. Okay, so these are never valid. So again, I just want to make sure that we're comfortable having the hypotheses presented in this form, or in this form as well. Okay. Okay, so okay, I guess that's what I said. Rejecting the null is equivalent to supporting the alternative. Not rejecting the null is equivalent to not supporting the alternative. Okay, so you either have enough evidence to support the alternative and reject the null, or you don't have that. Okay. The null hypothesis will always have an equal sign in it, and this means that the null hypothesis always states one of the following: that the population proportion is equal to some value, that two population proportions are equal to each other, a population mean is equal to some value, or that two population means are equal to each other. Okay, so let's try another question here. Okay, you want to create a hypothesis test to see if the proportion of men who whatever, okay, I don't know, is greater than the proportion of women who also do whatever. All right. This sounds, I don't know, whatever. Okay. All right. So what would the appropriate hypotheses be? Okay. So option A, the null is that we'll say P. I'm just going to do P1 equal to P2, and the alternative will be P1 not equal to P2. Option B will be the null is that P1 is not equal to P2, and the alternative is that P1 is equal to P2. C will be P1 equal to P2, and P1 is greater than P2. We'll say P1 less than P2. Okay, so we'll say proportion of men, this will be sample 1, and proportion of women will be sample 2. Okay, so go ahead and fire this up. Okay, looks like most of you guys got your answers in, so great. Okay, so the correct answer is C, which I think the vast majority of you guys got. Okay, so that's good. All right, so again, the null hypothesis always has an equal sign, so right off the bat we can eliminate answer choices C and D because there's not an equal sign there, okay? And then here it's talking about we want to test to see if the proportion of whatever, proportion of men who whatever is greater than the proportion of women who also do whatever, okay? So that is reflected right here with the greater than sign, and we're not using the not equal sign, okay? So answer choice C is correct. Okay, good. Okay, let's see, a few more things. I want to talk about p-values and then type 1 and type 2 error, okay? All right, we'll talk about the type 1 and type 2 errors. Okay, so type 1 error is rejecting the null when the null is true. Type 2 error is rejecting the null when the null is false. The significance level alpha is the probability of a type 1 error. Okay, so keep that in mind. And let's see. Oops, that's not what I want to do. Okay, so let's say maybe there's a. Oops. What is going on here? We'll say doctors can administer an STD test. Okay, the generally the test would assume that people are STD free unless they show symptoms of having a disease. Okay, all right, and so the null hypothesis will be patient is disease free, and then the alternative will be patient has an STD. Okay, all right. So let's, so here are your answer choices. Okay, type 1 error is worse than type 2 error. So we pick a large alpha. Answer choice B is type 1 error is worse than type 2 error, so we pick a small alpha. And then answer choice 2 will be type 2 error is worse than type 1 error, so we pick a large alpha. And then answer choice D will be type 2 error is worse than type 1 error, so we pick a small alpha. Okay, so think about this one. Okay. So think of what does it mean to commit a type 1 error? And what does it mean to commit a type 2 error? And keep in mind that alpha is equal to the probability of a type 1 error. Now both of these errors are bad. We don't want to make either types of errors, but I think we would agree for the most part that one type of error is worse than the other type of error, okay? Is that a question, or are you stretching? Okay, you're stretching. Okay, that's fine. You can stretch. All right, okay, do we have our clicks in? Okay, let's see. So I would say the correct answer choice is answer choice C. Where did the... Okay. All right, so type 1 error is a, quote, a disease-free person, gets a false positive. So, that's unfortunate. We don't want that, okay? But the type 2 error I think is worse, is that a diseased person, is quote, cleared, okay? And this will cause, transmission or spread of the disease. So this is a bad thing, okay? Because type 1 error is worse than type 2 error, so we would rather make type 1 over type 2. So we are willing, to increase our alpha. Over, willing to increase alpha rather than increasing our beta, okay? So answer choice C is correct there. Okay, we'll have that. I'll post all of these up so you can kind of review these as you review some of these conceptual type questions.